Okay, for the first question, we are given the density function, joint density function, which is a constant in the range x square plus y square is less than 1 and it is 0 otherwise. So, using the condition, we can find that the value of x is in the range of plus minus root 1 minus y square. So, using this range, we know that the integration will be equal to 1 for a valid joint PDF. So, then after some basic calculation and calculus, we find the value of b to be equal to 2i pi. Okay. In order to get the expectation of x as well as the conditional expectation of x and the expectation of x into y, for all these cases we just need to find the value of expectation of x, because while we put the value of b and do the integration in the range, we find that the expectation of x is 0. That's why the expectation of x given y, expectation of x into y, all of them will be also equal to 0. In order to find the expectation of y, we put the value of b and do the integration in the range. The y range is 0 to 1 and the x range is the given range, minus root 1 minus y square to plus root 1 minus y square. And after doing the calculus, we find out the expectation of y to be equal to 4 by 3 pi. For 7.2, we have been given that probability of A, probability of B, probability of C all are equal to 0.5, and probability of A times B, probability of A times C, probability of B times C, or we can say that intersections, and probability of A, B, C, or A intersection B intersection C is equal to 0.25. So we can easily see that probability of A into probability of B into probability of C, which will be 0.5 into 0.5 into 0.5, is not equal to probability of ABC. So the random variables x, xb and xp are not independent. But we can see that since probability of A into probability of B is equal to 0.5 into 0.5, which is 0.25, so that is equal to probability of A intersection B as well as probability of B intersection C and probability of A intersection C. Again, set A is equal to A intersection B union A intersection B bar. So using that property, let me focus this thing. Using that property, we can find out the probability of AB bar is also equal to 0.25 and probability of B bar is equal to 0.5. So we can say that probability of AB is equal to probability of A into probability of B, as well as probability of AB bar is equal to probability of A into probability of B bar. So using these properties, we can say that they are independent in pairs.